What if I told you there exists an ancient celestial body that seems to have been born even before the universe itself, or a vast, empty region of space that repels nearly all matter as if in defiance of gravity? And what about a galaxy that acts like a cosmic sprinkler, spraying matter outward in ways never seen before? You might think these are scenes from a science fiction novel, but they are all real phenomena hidden in the depths of the cosmos. Before we begin our exploration, feel free to share a small goal of yours in the comments. You never know, it might just come true. The journey ahead is filled with wonders, so listen closely and drift into a peaceful sleep. Some black holes, which should have long ceased their feasting, continue to devour matter at an astonishing rate. Some planets, rich in rare elements, sparkle and shimmer, looking more like jewels than worlds. And there are stars that pulse and flicker in inexplicable ways, hinting at forces we have yet to understand. Even more peculiar are the structures that exist in the cosmic void, structures that even our most advanced telescopes struggle to explain. On this cosmic journey, we will unveil 10 of the most bizarre and mysterious celestial objects. Some challenge our understanding of gravity, while others overturn the conventional wisdom of stellar evolution. Some hide in galaxies very close to us, while others reside at the very edge of the observable universe, a place where reality warps, time bends, and the impossible becomes possible. Because out there, in that vast sea of stars, the most peculiar objects in the universe await our discovery. The cosmos is full of mysteries, but some celestial bodies push the very limits of what we believe is possible. Imagine a celestial object brighter than an entire galaxy, a cosmic furnace burning with the energy of 500 trillion suns. But this is no ordinary quasar. It is far more extreme than anything we have ever known, a mystery that completely overturns our understanding of the early universe. According to our current theories, it simply shouldn't exist, at least, not in any way we can comprehend. But it does exist. To look at it is to gaze into the past. The light we see today has traveled through space for over 12 billion years. This means what we are seeing is how it looked when the universe was just 1.6 billion years old. The problem is, the mass of its core is estimated to be 20 billion times that of our Sunday. For an object of this age, such a scale is almost impossible. The standard cosmological model cannot explain how a celestial body could grow so immense in just over a billion years after the Big Bang. Even the most optimistic theories suggest that such a black hole would need several billion years to form, not such a brief period. To sustain such a ravenous cosmic behemoth, it must be consuming matter at a breathtaking rate. Observations show its accretion disk is a searing vortex of gas spiraling inward. Every second, it releases more energy than hundreds of galaxies combined. The forces at play in this system are far beyond human comprehension, even generating X-ray winds moving at 40% the speed of light. That means matter is being ejected at nearly 120,000 kilometers per second, fast enough to tear apart anything in its path. But what truly sets this system apart is another discovery hidden around it, one that completely upends our understanding of water in the universe. Incredibly, scientists have detected around this quasar a reservoir of water 140 trillion times greater than all of Earth's oceans. This is not an exaggeration. It is the largest and most distant reservoir of water ever discovered in the universe. And this water is not frozen solid, but exists as hot vapor, mixed with the scorching radiation from the central region. If this water were gathered in one place, forming a single massive ocean, it would span several light years. Water, the essential element for life as we know it, is usually associated with the formation of planets or atmospheres. But here, at this distant and inhospitable edge of the universe, it exists as vapor at a temperature as high as 53 degrees Celsius. It remains in a gaseous state, suspended in one of the most violent environments in the cosmos. This quasar also exhibits another unusual behavior. Its cycle of brightness variation cannot be explained by current black hole theories. Normally, the accretion disk around a black hole should exhibit a relatively regular pattern of light. with brightness gradually decreasing as matter falls in. But this one displays a strange, cyclical variation, brightening and dimming, without any discernible pattern. This suggests that something more complex might be happening within it. Some theories propose that within this system, there might be a hidden second black hole, engaged in an ancient gravitational dance. If this is true, it could involve a phenomenon called gravitational lensing, where space-time itself is warped, causing light to bend and creating the illusion of changing brightness. However, this remains speculation. What is certain is that this is no ordinary quasar. It is profoundly chaotic, forcing us to rethink how early galaxies and extreme celestial objects were formed. There's another puzzle. Its redshift is 3.91. As the universe expands, light is stretched, making this object seem closer than it actually is. This makes it one of the most distant, yet brightest quasars ever observed. Typically, an object so far away should be incredibly faint, but it is one of the brightest quasars known. This makes one wonder, in the distant universe, are there more of these ultraluminous quasars hiding? If so, our current models of cosmic evolution might be missing a crucial piece of the puzzle. One of the most dramatic features of this system is the high-energy particle stream it emits. Unlike most quasars where matter primarily flows inward, this one exhibits massive outflows and storms, ejecting matter outward. These flows are so powerful that they may be reshaping the entire intergalactic space around them, even preventing star formation in the centers of nearby galaxies. In a way, this quasar is not just a consumer, but also a destroyer. It is transforming a vast expanse of the surrounding cosmos. This extreme activity suggests it might be in a transitional phase of cosmic evolution, shifting from an earlier form into a completely new type of celestial object. Will it eventually stabilize and become a normal galaxy, or will it continue to exist in this chaotic state? No one knows. But what is certain is that it's a paradoxical existence. It shouldn't be this massive. It shouldn't be this bright. And yet, it exists in the universe's youngest era. Even today, our understanding of it is filled with questions. Does it reveal a completely different way for galaxies to grow? Did it bypass the standard evolutionary path and form from a direct collapse? Or perhaps, is it driven by some more exotic mechanism we have yet to discover? Whatever the truth may be, it remains one of the most peculiar and incredible cosmic objects known to us. A quasar so bright, so powerful, and so ancient, it forces us to rethink the very limits of the universe. The cosmos is full of mysteries, but some celestial objects fundamentally challenge our basic understanding of space. In the skies of the southern hemisphere, in the direction of the constellation Norma, lies a strange object that has puzzled astronomers for decades: Andromeda X1. It is a binary star system, but unlike any other we have ever seen. At first, it appeared to be an ordinary X-ray source. However, upon closer inspection, we discovered something extraordinary was happening. It was as if it were alive, consciously twisting and reshaping itself. The plasma jets it erupts do not shoot straight outward, but instead rotate like a sprinkler, deflecting and spraying matter across space in a way we have never witnessed before. What makes this system so different? To solve this mystery, we must first understand the nature of Andromeda X1. It is not a single star. Instead, it is a deadly combination of two celestial bodies, a neutron star and a much larger companion star. The neutron star is the remnant of a massive star's explosion. It is incredibly dense, with a gravitational pull so strong that it strips matter away from its companion. As this stripped matter spirals down toward the neutron star, it is heated to extreme temperatures, forming intense X-ray radiation. This makes Andromeda X1 one of the brightest X-ray sources in the Milky Way. But its peculiarities go far beyond its brightness. The matter ejected by this system moves at incredible speeds, some of the fastest jet velocities ever observed, approaching the speed of light. This high-speed plasma collides with the surrounding space, creating shockwaves that ripple through interstellar space. But the strangest part of all are those twisting, sprinkler-like jets. In typical black hole or neutron star systems, jets are usually stable and straight, shooting out in a fixed direction. but the jets of Andromeda X1 wobble and rotate as if guided by an unseen hand. Observations from South Africa's Meerkat radio telescope show these jets completely defy our understanding of astrophysical jets. They spin like a garden sprinkler, spraying high-energy particles in a wide fan. This phenomenon is believed to be the result of a neutron star, the result of a complex gravitational dance between its accretion disk and the powerful magnetic fields woven within. But the story doesn't end there. Andromeda X1 is also one of the youngest X-ray binary systems we know of. Unlike most neutron stars, which are millions or even billions of years old, this one is only a few thousand years old. It's still enveloped in the remnants of the supernova explosion that created it. This means we are witnessing the evolution of a young system in real time, a stage of life never observed before. This neutron star isn't just consuming matter, it's actively shaping the space around it as its jets collide with interstellar gas, forming termination shocks, regions where matter abruptly slows down, releasing immense energy. Such shock waves have never before been detected in an X-ray binary system. Andromeda X1 is therefore seen as a unique laboratory in the cosmos for studying these shock waves. It can help us understand how neutron stars interact with their environment, and also offers clues for exploring larger-scale cosmic phenomena, like the evolutionary mechanisms of satellite galaxies and entire galaxies. But what's most unsettling is its orbital motion. Most binary systems have stable, circular orbits, but Andromeda X1's orbit is a highly elongated ellipse. This means the distance between the neutron star and its companion is constantly changing, causing its accretion rate to speed up and slow down. Its energy output fluctuates dramatically as well. Sometimes the system flares up, unleashing powerful jets, while at other times it falls silent, as if in a deep slumber. This extreme instability makes it one of the most unpredictable objects in the entire universe. What's even more baffling is its erratic X-ray brightness. At times, its luminosity reaches extreme levels, and then suddenly plummets, as if obscured by something. To this day, the reason for this irregular behavior remains a mystery. Some scientists speculate it might be related to a dense cloud of material enveloping the system, perhaps debris left over from that supernova explosion. There is another unsolved mystery. This system is hurtling through the Milky Way at a breathtaking speed. It's one of the fastest-moving X-ray binary systems known, traveling at over 1 million kilometers per hour. This suggests that the supernova explosion at its birth gave it a tremendous kick, sending it flying like a bullet through interstellar space. And Andromeda X1 doesn't behave like a typical neutron star. Some models suggest it might be transitioning into an even more exotic state, perhaps forming a quark star, an object composed of the most extreme matter in the universe. If this is true, it would be a major breakthrough in modern physics, because this state of matter has, until now, only existed in theory. Every new observation brings more questions. The Meerkat telescope continues to track its changing jets, but each new set of data only makes the overall picture more complex. Andromeda X1 is one of the most incredible celestial objects we have ever discovered. It challenges our understanding of how neutron stars form, how they interact with their environment, and how they evolve. Despite being studied for over 50 years, it remains an unsolved enigma. We don't know how long its jets will last, nor if it will ever settle into a stable state. We don't even know if it will ultimately collapse into an even more extreme existence. It reminds us that even in the age of modern astronomy, even when we can gaze to the edge of the universe, there are still inexplicable objects within our own galaxy. Andromeda X1 is a mystery, an astronomical puzzle that might take decades, or even centuries to truly understand. But as long as it remains in our sights, it will continue to challenge our perception of the cosmos, silently conveying secrets that only the future may unlock. Across the depths of space, nearly 1 billion light-years away, lies a vast void where almost nothing exists. It is the Eridanus Supervoid, one of the largest cosmic structures known to us. However, its immense size isn't the strangest thing about it. What's more perplexing is its connection to an unsolved cosmic anomaly, the cold spot in the cosmic microwave background radiation. This is the temperature afterglow of the Big Bang, and according to standard cosmology, this region should not be so cold. Its existence shatters our understanding of the temperature distribution in the early universe. Scientists have tried to explain this anomaly with various theories, from quantum energy fluctuations to the imprint left behind by a collision with another universe. But to this day, no single theory can fully explain the origin of the Eridanus Supervoid. To grasp the significance of this mystery, we first need to understand what cosmic voids are. The large-scale structure of the universe resembles a web. Galaxies are distributed in filament-like structures, forming clusters and superclusters, and between them lie vast, low-density spaces, known as cosmic voids. These voids are not entirely empty, but are regions with far fewer galaxies than others. Due to a lack of sufficient gravity, these regions also expand faster. Most cosmic voids span from tens of millions to a few 100 million light-years across. But the Eridanus Supervoid is different. Its diameter is nearly 1 billion light-years. It is one of the largest voids ever observed. The first clues to its existence came from an even stranger phenomenon, the cold spot in the cosmic microwave background. The CMB is the earliest light from the universe, faintly covering the entire sky, forming a nearly uniform blanket of background radiation. However, in the direction of the Eridanus constellation, astronomers discovered a patch that is significantly colder. Although the temperature difference is only a few microkelvins, it is statistically significant and cannot be explained by random fluctuations. This cold spot. Could it be caused by the Eridanus Supervoid? One explanation is the integrated Sachs-Wolf effect. As CMB photons travel through the void, the expansion of space causes them to lose a tiny amount of energy, resulting in a drop in temperature. If the void's scale and depth are as vast as estimated, it might be large enough to create such a cold spot. The problem is, standard cosmological models suggest that even a void of this magnitude is not enough to cause such a significant temperature difference. This has led to more radical theories. Some have proposed that the cold spot might be a scar left by a violent quantum fluctuation in the fabric of space-time in the early universe, a wound from the chaotic phase of the Big Bang. An even bolder idea is that the supervoid and the cold spot might be the result of two universes colliding, serving as evidence for the multiverse theory. According to this theory, our universe may be just one of countless bubble universes, and in their early stages, these universes might have collided. Some cosmologists believe the cold spot could be the bruise from one such cosmic collision, and the Eridanus Supervoid is the evidence of how that impact permanently altered the structure of space. Of course, these explanations are highly controversial. Most physicists still lean toward a more conservative view. It is an unusually large void that happens to coincide with the cold spot. Yet, even this explanation still challenges our current models of cosmic structure. If voids are simply the natural result of density fluctuations in the early universe, then a structure on the scale of Eridanus should be extremely rare. Some models even suggest that a void like it is almost impossible to form. And yet, there it is, leaving scientists even more puzzled. Future observations may bring answers. For instance, the Euclid Space Telescope is planning to map the large-scale structure of the entire universe, while also studying the distribution of dark energy. And the upcoming Vera C. Rubin Observatory will also scan the entire sky to an unprecedented depth, searching for similar structures. If more supervoids can be found in other regions, then we might determine that this is not just a coincidence, but a hidden pattern in the structure of the cosmos. For now, the Eridanus Supervoid remains a mystery. Is it an extreme product of cosmic evolution, a relic of an ancient cosmic event, or a clue revealing new physics, or even the existence of a multiverse? The answer is not yet known. But one thing is certain: this void is far more than just emptiness. It is a giant question mark written into the fabric of the universe, a cosmic riddle that science has yet to solve. There is a celestial body traveling through the Milky Way faster than almost any other star. It is the burnt-out remnant of a star, hurtling through the cosmos at an unimaginable speed, as if nothing can stop it. This is LP 40-365, a white dwarf that should have been completely obliterated in a cosmic explosion. But not only did it survive, it was launched through the galaxy as if fired from some invisible cannon. Stars aren't supposed to behave this way. They are born, they burn, and they end their lives as black holes, neutron stars, or white dwarfs. But LP 40-365 breaks these rules. Its speed exceeds 850 kilometers per second, so fast that one day it may escape the gravitational pull of the entire Milky Way. The story of this star is clearly extraordinary. It endured a cataclysmic event that should have been its end, yet miraculously, it survived. A white dwarf is the dense core that remains after a star like our Sun has exhausted its nuclear fuel under normal circumstances. They are usually quite stable, but if a white dwarf gathers too much mass, exceeding a critical limit, it will erupt in a supernova explosion. This explosion would normally have vaporized the star, leaving no trace behind. And yet, LP 4365 still exists. So, what truly happened? The answer is even stranger than you might imagine. Scientists now believe LP 40-365 was once part of a binary star system orbiting another white dwarf. Over time, their orbits spiraled closer and closer together. Its companion star gradually siphoned away its material, growing more and more massive until it reached a critical point. At that moment, a catastrophic nuclear explosion ignited a thermonuclear blast that should have obliterated the entire system. But the explosion failed. It wasn't a complete supernova, but a partial one, an attempted blast that didn't quite succeed. One star was torn apart, while the other was violently flung out into space, becoming the LP 40-365 we see today. What's even stranger is its elemental composition, which is unlike anything seen before. Typical white dwarfs are made mostly of carbon and oxygen, but LP 40-365 is rich in oxygen, neon, and magnesium, the byproducts of a strange nuclear reaction. It's like a fragment of supernova ash that wasn't completely destroyed. This discovery also supports a new kind of supernova theory known as the D6 model, or the double detonation model. Simply put, sometimes the explosion in a binary system isn't total, leaving behind a fragment like LP 40-365. LP 40-365 is one such shard, a living remnant of a cosmic catastrophe hurled out into the universe. It is hurtling through the cosmos at an incredible speed, journeying through interstellar space. But if this theory is correct, it raises a more unsettling question. What happened to its companion? If the explosion failed to destroy LP 40-365, does that mean its companion also survived in some form? Could there be another hypervelocity white dwarf, wandering silently somewhere in the cosmos, a second survivor of that failed explosion? So far, scientists have found no sign of it. It may have been completely vaporized in the explosion, or it could still be drifting, alone, in the distant interstellar void. The discovery of LP 40-365 forces us to rethink how stars die. We used to think that once a white dwarf's mass surpassed its limit, it would inevitably explode. But now, it seems the universe is far more chaotic and unpredictable than we ever imagined. If LP 40-365 could survive a partial explosion, could there be more such stars in the universe? Are there countless other fragments influencing the structure of galaxies in ways we haven't yet noticed? Perhaps future observations will provide the answers. Astronomers are now searching for more runaway white dwarfs to see just how common these failed supernovas are. If more stars like LP 40-365 can be found, it would show this isn't an isolated accident, but a regular hidden phenomenon of the universe. A mechanism of galactic evolution we've previously overlooked. Generally, the shapes of galaxies are predictable spiral, elliptical, or irregular. These structures have been widely studied, as have the supermassive black holes at their centers, which guide the evolution of their entire galaxies. Bending space-time, consuming matter, and ejecting enormous jets of energy. But then, astronomers discovered a completely baffling phenomenon in a small number of galaxies. Their jets didn't form the expected symmetrical, two-lobed structure. Instead, they formed a perfect X shape. This structure, spanning hundreds of thousands of light years, completely upended our understanding of black hole jets. Why would a black hole eject matter in completely different directions? What forces could possibly be at play? More importantly, are these rare celestial objects revealing some fundamental mechanism of the universe we don't yet understand? At first, these X-shaped galaxies looked like observational errors, perhaps image artifacts, or instrumental glitches. But later, scientists repeatedly observed the same structures in multiple different viewings. They weren't a coincidence, nor were they an illusion. They were real. In a typical radio galaxy, a black hole ejects high-energy jets from the poles of its rotating accretion disk, perpendicular to the plane of the galaxy. These bipolar jets are well established in theory and are predictable. In X-shaped galaxies, however, things get strange. In addition to the two primary jets, there are two more distinct jets pointing in a completely different direction, forming a giant cosmic X. The most famous example is NGC 326, an elliptical galaxy about 200 million light-years away. Its structure clearly displays this impossible X, as if the black hole at some moment in time suddenly changed the direction of its jets, rerouting energy from old pathways to new ones. So, how on earth did this happen? The initial explanation was a black hole merger. When two supermassive black holes fuse after their host galaxies collide, their spin axes can change dramatically, causing the jets to point in a new direction. The remnants of the old jets would still linger in space, while the new jets forge a different path, creating the crossed structure. This theory is supported in some cases, because galactic mergers are common and black hole mergers are known to alter jet directions. The problem, however, is that some X-shaped galaxies show no signs of a recent merger. Their structure is pristine and undisturbed. If they haven't experienced such a violent event, then why would their jets suddenly change course? This led to a second theory: plasma backflow. According to this hypothesis, after the primary jets shoot out, some of the high-energy material is pushed back by pressure from the surrounding medium. It flows back toward the galaxy along the sides, creating what look like phantom jets. This returning plasma could be what creates the X shape we observe. While this theory explains the secondary jets in some galaxies, it also has its problems. A structure created by backflow should be fuzzy, diffuse, and fading over time. But the secondary jets in some X-shaped galaxies are crisp, well-defined, and energetic. They don't look like a faint echo, but more like independent, ongoing eruptions. And so, a third possibility emerged: a flip in the black hole's spin axis. This means the direction of the black hole's own rotation changed dramatically. If a black hole were to suddenly absorb a large clump of matter coming from a different direction, or if it were disturbed by the extreme gravity of a nearby object, its spin axis could be forcefully reoriented. This axial shift would cause the direction of the jets to change in an instant. Meanwhile, the old jets would remain, lingering in space, creating an intersection of the old and new streams, forming the X-shaped structure. This theory is more compelling and matches the observed features of certain galaxies. But questions still remain. What kind of incredible force would be needed to flip the spin axis of a supermassive black hole? Is there some cosmic scale force we haven't yet discovered that is orchestrating these changes? As radio telescope technology improves, scientists are discovering that X-shaped galaxies aren't as rare as they once seemed. They hide in all corners of the universe, and perhaps they aren't exceptions, but rather a normal phase of galactic evolution that we have yet to fully understand. And there's another mystery. Why are these X-shaped structures so perfectly symmetrical? Nature rarely creates such precise geometric patterns, unless there's an underlying law or mechanism at play. Could there be some undiscovered fundamental principle governing how black holes evolve? The discovery of these X-shaped galaxies is forcing us to completely re-examine the dynamics of black holes. We used to think that the direction of a black hole's jets was stable, lasting for millions of years and only changing slowly when disturbed by outside forces. But now, it seems these jets can suddenly reorient themselves in an astonishingly short period of time, perhaps even adjusting back and forth, completely transforming the structure of their host galaxy. If this is true, it means our understanding of how black holes behave is far from complete. They may be hiding a cosmic power we have yet to grasp, a mechanism that runs deeper than general relativity. Perhaps the jets themselves are a signal, silently revealing the unknown physics hidden within black holes. To this day, no single theory can fully explain why X-shaped galaxies exist. They remain one of the great puzzles of the cosmos, leaving us with one unanswered question after another. In the far reaches of the cosmos, in a galaxy known as J1144, there is a black hole, devouring its surroundings at a rate that seems to defy the laws of physics. This isn't just a gentle feeding, it's an absolute frenzy. It is growing so fast that it has shattered our understanding of the limits on how fast a black hole can grow. In theory, a black hole's feeding rate is capped by a natural speed limit, known as the Eddington limit. As matter spirals into a black hole, it heats up and releases intense radiation. This radiation exerts an outward pressure, pushing back against any more material trying to fall in, effectively acting as a brake. This mechanism is the natural balance that regulates the growth of black holes throughout the universe. But the black hole in J1144 completely ignores this. Its radiation shines far brighter than the Eddington limit would allow, which means its accretion disk is swallowing matter at a breathtaking rate, unleashing a torrent of light so scorching and brilliant it can outshine its entire galaxy. Normally, this kind of energy output should blow away all the surrounding gas and dust, making it impossible for the black hole to keep feeding. But it hasn't stopped. One possible explanation is that its host galaxy experienced a massive collision in its past. Vast clouds of gas were funneled by gravity toward the center, creating a high-speed river of matter that is now pouring directly into the black hole. Such events can indeed trigger intense black hole activity after galactic mergers, but even so, it should still be constrained by the Eddington limit. Another, more extreme theory suggests this black hole might be in a state of supercritical accretion, meaning that matter is plunging into the black hole at such a high density and velocity that it severely warps the surrounding spacetime, shattering our conventional understanding of the accretion process. This mechanism might allow it to bypass radiation pressure, devouring endlessly like a bottomless pit. If this theory holds true, then our models of black hole growth must be completely revised. Others have proposed that the fuel around Li 568 might itself be exceptionally unique, not ordinary gas and dust, but dense celestial bodies, such as neutron stars, white dwarfs, or even entire planets being swallowed one by one. These high-energy collisions could be the very root of the intense radiation and erratic changes in brightness. An even more unsettling hypothesis is that behind all of this, there may be some unknown physical process at play. Some theoretical physicists believe that extreme black holes like Li 568 might be linked to new forms of matter beyond the standard model, such as dark matter interactions, quark matter, or even some yet undefined cosmic engine. What we do know is that the plasma and particle jets it ejects are like cosmic blades slicing through the galaxy's gas. These jets can stretch for thousands of light years, traveling at nearly the speed of light, generating powerful magnetic fields and heating the interstellar gas to temperatures hotter than the core of most stars. If it continues to grow at its current rate, it will quickly become one of the most massive celestial objects ever known. Normally, supermassive black holes take billions of years to form, yet this one may have taken a remarkably short time to reach the same level of mass. So the question arises, when a black hole shatters all known limits, what happens next? One theory suggests that when a black hole feasts too quickly, it might choke, releasing an extreme burst of energy before temporarily going dormant, only to resume its normal state. This process of binging and pausing has been observed in some quasars. Others speculate that an excessively growing black hole might undergo even more dramatic changes, like suddenly expelling most of its matter, triggering an explosion more powerful than a supernova that could tear the entire galaxy apart. An even more cutting-edge theory suggests that if the black hole's feeding behavior completely defies convention, it might enter an entirely new state of matter, a thick black hole state that we cannot yet define. It would no longer be a structure purely governed by gravity, but a new kind of cosmic phenomenon, one that could reshape our understanding of space-time. And the most crucial question is Li 568 just an isolated case? If one such black hole exists, there could be more. Does it reveal a neglected path of cosmic evolution? Are there more black holes growing at super speed, silently active somewhere in the cosmos? For now, the puzzle remains unsolved. But of one thing we can be certain. In some corner of the universe, a black hole is feeding at an unbelievable rate. Its next transformation might just upend everything we know about the cosmos. In the night sky, there is a star that appears exceptionally large. Its apparent diameter, an astronomical marvel. It is the red giant, Eridanus. Located only about 200 light-years away, its mass is far less than that of the true cosmic behemoths, yet its relative proximity and peculiar structure make it a perplexing enigma in the world of astronomy. This red giant pulsates in a slow, rhythmic way, its outer shell seeming to expand and contract as if it were breathing. It belongs to the class of Mira variable stars, whose brightness changes over time. But unlike typical variable stars, the variations of Eridanus are very gentle, almost like a whisper rather than a violent flicker. Its diameter is a staggering 370 times that of our Sun, and yet it seems fragile. Its surface gravity is incredibly low, allowing massive convection cells to churn freely across its surface, making the star look as if it's boiling. This state of dynamic expansion places Eridanus in a state of critical balance, unstable, yet not on the verge of collapse. What's most curious is that the apparent diameter of Eridanus is the second largest in the entire sky, second only to Betelgeuse in the constellation Orion. Yet, compared to that true supergiant, the mass of Eridanus is actually quite modest. So why does it appear so immense in the sky? The answer lies in its incredibly bloated outer shell, a tenuous layer of gas enveloping the star, extending far beyond its actual core. This gaseous layer diffuses like a mist, scattering the starlight outward and making it appear exceptionally large through a telescope. This might mean it's in a crucial, critical phase, the final leg of its stellar evolution about to unfold. In the final stages of their lives, red giants gradually shed their outer layers of matter, forming a shell of dust and gas that envelops their core, eventually evolving into a planetary nebula. And after this, Eridanus will be left with only a white dwarf core, destined to cool and slowly fade away. But before then, it remains in a liminal state, no longer stable, yet not quite ready to fall apart. We can glimpse its internal structure through its pulsations. As the hydrogen fusion in the star's core gradually wanes, its outer layers expand and contract like the gentle rise and fall of water's surface. These oscillations cause periodic changes in the starlight, allowing astronomers to infer its internal structure. By observing these variations in brightness, the massive convection cells on its surface are each large enough to swallow an entire planet, making the entire star seem to churn and boil. More importantly, the star Eridanus is casting elements out into space. As this material is gradually expelled, the resulting clouds of gas and dust are rich with heavy elements, like carbon and oxygen. Over time, they will drift through the interstellar medium, becoming the raw materials for future stars and planets. In other words, the end of Eridanus is not a finality, but the beginning of a new cosmic cycle. Its remains will go on to nourish new stellar systems and new worlds. However, some scientists suspect that its evolution may not have been so peaceful. Some red giants exhibit highly asymmetrical behavior when they lose mass, sometimes even experiencing violent mass ejections. This process could be triggered by a hidden companion, such as an unobserved planet or a small star, that is disturbing the star's outer layers. At present, no companion has been confirmed around Eridanus, but its complex and ever-changing outer structure leaves much room for speculation. Another unresolved question remains: what will its final moments be like? Some models predict that toward the end of its life, it may experience irregular eruptions, manifesting as sudden flares in brightness, with shock waves piercing its outer gaseous shell, or high-energy stellar storms that disturb the surrounding interstellar environment. The more we observe Eridanus, the more mysteries emerge. Why are its pulsations more stable than those of other Mira-type variables? Does it hide a deeper structural instability? And its vast, tenuous outer shell, how will that influence its ultimate fate? For astronomers, Eridanus is a living lesson, a star in the slow process of evolution. Every pulsation, every ejection of matter, is a piece of the future cosmic tapestry. It is destined to fade, eventually becoming a faintly glowing shell of gas, leaving behind only a pale white dwarf core. But until then, it will remain in its immense form, hanging high in the night sky, a testament to the glorious final chapter of a red giant. In the darkness of the cosmos, there is a celestial object known for being ruthlessly cold. Not even its own companion star can escape its grasp. It is not a black hole, but a pulsar, a rapidly spinning neutron star. But its existence is like a cosmic executioner, slowly and relentlessly stripping the life from its companion. This is PSRJ 600, an object classified as a Black Widow pulsar. It is in the midst of a cosmic murder, a silent disintegration of its companion. Pulsars are typically seen as cosmic lighthouses, emitting radio waves in precise intervals. But Black Widow pulsars are the most extreme of their kind. Not only do they spin incredibly fast, but they are also literally vaporizing their companion stars. This pulsar's rotation is astonishing, spinning hundreds of times per second, making it a millisecond pulsar. This means it once siphoned a vast amount of material from its companion, spinning itself up to extreme speeds. Now, its gravity continues to pull at the companion's outer layers of gas, drawing that material onto its own surface to sustain its high-energy state. However, the true destruction comes not from gravity, but from radiation. The electromagnetic radiation from the pulsar acts like an invisible inferno, stripping away the companion's surface layer by layer. This erosion is slow but irreversible. The companion star is gradually shrinking and will eventually become nothing more than a scorched remnant, unable to escape, unable to fight back. Scientists discovered this system using radio telescopes. At first, it appeared like an ordinary pulsar signal, but they soon noticed that at certain times, its signal would flicker faintly. This hinted that a companion star was orbiting it, periodically eclipsing the signal. The true nature of this companion remains a mystery. Some believe it is an extremely low-mass brown dwarf. Others speculate that it is a planetary remnant, the outer shell of what was once a complete star, now almost entirely consumed by the pulsar. It once shone with its own light, but now only a scorching outer shell remains, struggling to survive in the cosmos. Some studies even suggest that it could eventually evolve into an extremely rare type of pulsar planet. That is, a celestial body formed from the remnants of a destroyed star, yet still held captive by the pulsar. And what's more wondrous is that these Black Widow pulsars are not just cosmic killers. The intensity of their radiation can also influence the surrounding interstellar gas, triggering the formation of new stars. A system in the midst of its own destruction might indirectly nurture new life. This paradoxical cycle is the very essence of the cosmos. In our Milky Way, we have already found several Black Widow pulsar systems. Each one showcases a different stage of destruction. Some companion stars are desperately shedding gas, attempting to escape in their final moments. Others have disappeared completely, leaving behind only a solitary millisecond pulsar, still spinning at an incredibly high frequency, like a ghost whose mission is done. So what does the future hold for this particular pulsar, if it follows the path of other Black Widows? Its companion star will gradually evaporate over the next few million years until it vanishes completely, leaving behind only a solitary neutron star spinning on in the darkness, a world ender with no prey left to hunt. What was once an active star is now just torn and melted gas, slowly dissolving back into the interstellar dust. And the executioner spins on, scanning, waiting for its next target. But a deeper question remains. How many such systems are there? If we have already discovered dozens, does that mean that within the Milky Way, there are thousands upon thousands of star systems that have already met a silent destruction? Were there even systems that once nurtured planets, that were also completely extinguished in the light of a pulsar? Black Widow pulsars reveal a cruel side of the cosmos. It is not only a source of magnificence and wonder, but also a symbol of cold, ruthless endings. Perhaps in the distant future, when this pulsar exhausts its energy and slowly fades, it will no longer be a killer, but merely a silent neutron rock floating in the cosmos. But until that day comes, it will continue its mission, silently executing the end of a star in the cosmic deep. In the dark depths of the universe, there lies a structure we cannot comprehend. Immense rings of light, floating in the void between galaxies. Like cosmic ghosts, they appear as perfect circles, yet cannot be explained by any of our current physics. These mysterious structures are called odd radio circles by astronomers. Their sheer scale is astonishing, with diameters reaching up to 1 million light-years, yet we know almost nothing about them. The first discovery was made in 2019 by Australia's Square Kilometre Array Pathfinder telescope. During a routine sky survey, it accidentally detected a vast, faint, ring-shaped radio structure. At the time, astronomers believed it was simply an image processing error, but when they went back to double-check, they realized it was real. Subsequently, several more similar structures were discovered, and by 2020, at least 5 odd radio circles were confirmed. These structures share several common characteristics. They are immense. They are visible only in radio wavelengths, showing no signs of existence in visible light, X-rays, or infrared. Most have no obvious central galaxy connected to them, and there is no evidence of any explosion or impact. They are like giant halos that have appeared out of thin air, existing without any clear origin. The diameter of each one is more than 10 times the size of our Milky Way galaxy. It's a scale that makes imagining their origin a true challenge. Normally, an explosion or impact of such magnitude should leave clear traces of energy in other wavelengths, such as X-rays or gamma rays. But the radio circles are completely silent in those bands. They emit only a faint, stable radiation in the radio frequency band. Most baffling of all is their geometric shape. Each one is an almost perfect ring. In the cosmos, structures that form naturally rarely exhibit such precise symmetry. This hints that there might be a single underlying physical process at work, or perhaps a natural mechanism that is entirely unknown to us. One theory is that they might be remnants of ancient galactic collisions, or the lingering shockwaves from a black hole merger. But if that were true, they should be expanding rapidly, or have already become faint and diffuse. Yet observations show they are remarkably stable, with no obvious signs of expansion or decay. Another theory proposes they are the edges of a sort of cosmic bubble, the two-dimensional projection of an immense three-dimensional, spherical structure. The ring we perceive would actually be the cross-section of a much larger sphere. But what could have created such a sphere? And how could it remain structurally intact for billions of years? There is an even bolder hypothesis that these rings might be fossils of early quasar activity, the remnants left behind after extremely active quasars ejected high-energy jets. This residual plasma in the intergalactic space could have formed a ring. However, most odd radio circles do not have a quasar or an active galaxy at their center, which contradicts this theory. An even more extreme speculation is that these structures might be connected to dark matter, or the interactions of some unknown particle, or even a fundamental physical phenomenon of the universe that we have yet to discover is at play. In some of the current images of these radio circles, we can also see filament-like structures inside the rings, like a woven pattern of radio waves, displaying a symmetry that is hard to explain. These details only deepen the mystery. What kind of force, operating on a scale of millions of light years, could have sculpted these intricate patterns? If they are indeed a new type of celestial structure, then a chilling question arises. Are structures like this common, and we simply lack the technology to detect them before? As the sensitivity of radio telescopes increases, we will likely find many more odd radio circles. Does this mean the universe is filled with these phantom rings that have just been hiding beyond our sight? Even more unsettling, they don't seem to be moving at all. If they were shockwaves from an explosion, they should be expanding. But the radio circles appear like patterns imprinted upon the cosmos itself, neither expanding nor fading away. This has led some scientists to suspect whether these structures might be permanent scars left behind by some violent event in the early universe. Are they a kind of fossilized signal? And another mystery remains. What is their source of energy? A pulsar, or an active galaxy, has a clear source of radiation, but these radio circles have no discernible engine. Where does their radio emission come from? Even cosmic rays cannot account for their regular shape and vast distribution. The only certainty is that our current understanding of physics is insufficient to explain the existence of these colossal phantoms. They are not galaxies, nor supernovae remnants, nor the jets from a black hole. They are a new type of object, something we have never seen before, an unnamed cosmic structure. Future telescope projects, like the full square kilometer array, may be able to capture these structures in greater detail. But for now, odd radio circles remain among the most bizarre and incomprehensible objects in the cosmos, floating like ghosts in a sea of stars. Silent, yet unmistakably present. Each time a new one is discovered, we move a step closer to the deeper truths of the universe. Perhaps, in the near future, we will have to redefine the very meaning of a celestial object, to include them in our cosmic knowledge. But until then, they remain an enigma. At the heart of the Abell 2261 galaxy cluster, there lies an object that should not exist. A black hole of unimaginable size, with a mass 30 billion times that of our Sun, making it one of the most massive ever observed. Its existence is more than just an astronomical figure. It is a challenge to our fundamental understanding of how black holes form and grow. What makes this black hole so extraordinary is not merely its colossal size, but the fact that it shouldn't be so massive. According to current theory, the growth of a black hole is limited. As we've touched on before, the Eddington limit prevents a black hole from endlessly consuming matter. When the radiation pressure from infalling material becomes too great, it pushes matter away, preventing the black hole from feeding further. This mechanism is considered the natural braking system that regulates the growth of black holes. But the black hole in Abell 2261 has apparently ignored this rule. Its mass is so enormous that it surpasses the upper limits allowed by all theories. So, how could it possibly have formed? One possibility is that it is a primordial black hole, born in the early universe. These aren't formed from the collapse of stars, but are instead created directly in the extreme, high-density conditions right after the Big Bang. If this is true, then it might have begun consuming matter right from the dawn of the universe, and after billions of years of mergers and growth, it reached the size we see today. But the problem is, even according to this model, its growth rate is still unreasonably fast. Standard theory suggests a black hole's growth requires a delicate balance between absorption and feedback. Excessive consumption should lead to powerful energy outbursts that would then inhibit further growth. But this black hole seems to have skipped all of these steps. Does this mean, are some key mechanisms missing from our model of the universe? Could it be that certain black holes, under special conditions, can bypass the usual feedback mechanisms and grow without restraint? Or perhaps we have underestimated the density of matter in certain regions, or overestimated the power of radiation pressure. Another possibility is even more wondrously strange. This black hole might not be the ordinary kind we imagined it to be. Theories suggest it may not have begun as a single point, but as a far more exotic cosmic structure, like a higher dimension or a condensation of dark energy. In other words, it may not be a product of our three-dimensional universe at all, but a projection from a higher dimension, cast upon the fabric of our own. If this idea holds true, then this black hole is more than just a question of mass. It is a window into a deeper layer of the universe's very structure. What we are witnessing is a physical phenomenon beyond our comprehension, an existence that our current dimensions cannot fully describe. And while this explanation seems extreme, the wonder it inspires cannot be ignored. If such black holes are not isolated cases, but a common sight across the cosmos, then we may need to rewrite our entire understanding of how black holes evolve, how galaxies grow, and even the ultimate fate of the universe. And there is an even more humbling thought. If these supermassive black holes can grow without end, will they one day merge and flow into one another, forming a structure that transcends galaxies? Could it be that the great journey of the universe is slowly leading to a future ruled by black holes? An ultimate destiny where all matter, all galaxies, all light is finally drawn into one immense gravitational heart. We cannot yet know if the birth of such black holes is common, but we know that they are real. And they are sending us a message that our understanding of the cosmos is far, far from complete. The path of science is often lit not by the rules we have mastered, but by the exceptions we find. This black hole is the most profound of all exceptions, an existence that asks for an explanation, one that cannot be ignored. It reminds us that in the boundless cosmos, there are still so many wonders our current theories cannot embrace, waiting for us to find them. And all that we believe we understand may only be the tip of a cosmic iceberg.